All right. So today is like the lesson of random. I apologize. It's three distinctly different things. We need to explore the idea of instant versus average, and then we're gonna back up and like talk about just limits. What?
No. No, we just
In what?
in
Physics?
Yeah.
Cool. What's the difference between average and instant?
Average is like through the whole time,
Great explanation.
and then instance like at that singular part.
That made a lot of sense.
Yeah.
Sure, you want to start?
So I agree, and I'm not sure my presentation is going to be much better, but we're going to give it a go. Also, quizzes are graded, grades are in, most of you did very well. Those of you who did not, we need to talk about, like, some of you took calculus over the summer. Those of you who did that, really bad choice, we never, ever, ever recommend that. You are condensing 10 months of really dense material into 6 weeks. So retention is really kind of not great because you didn't have 10 months for it to soak in. And honors over the summer is largely non-existent. It's just, oh my God, here's calculus or pre-calculus. Trig, functions, cool, go. So, those of you who did that, my recommendation is to take pre-calculus here again. Because some of you are like 9th and 10th and 11th graders. Those that do it ahead of time are often 10th graders. Get out of my class. Heart, love you, want you in the right place. Anyway, all right, so topic 1 of random today, average versus instant. As these guys just said, average, if you want your average speed, you want to find out how far did you go in how much time, right? Yes.
Just question, was the answer to the question you had last time 100?
I believe so. The kayak question,
Yeah.
100. Some people have given me, I have pictures of them, proofs of it being 108. I believe they're double counting, but I haven't been able to identify all of that yet. But those of you who tried the kayak problem, 100. Okay, so how do you find your average speed? Well, you do distance, change in distance over the change in time. So I would like you guys to find the average speed of a rock if you're just standing over a hole, we'll say. This is the position over time. Find its average speed. Where is it in 2 seconds? Where is it in 0 seconds? Divide by the time. So calculate that. Who is here and who is not? Bill, Ashley, Alex, Ben, Vishali, Abigail, Caliana, Megan, Zach. What does this equation look like? Slope. And you know what? It totally is slope. All right, f of 2, 16 times 2 squared, minus f of 0, 16 times 0 squared. Ryan, what are the units on this?
Feet per second.
Feet per second. So that's your average speed of the rock. Drop the rock, gravity works, negative 16, or sorry, negative 32 feet per second squared every, put you there. Okay. I want to know instant speed, so what we just did was we found average rate of change. We found the slope of the secant line. We found that change. I'm gonna ask you guys to do some calculations and I'll explain in a minute, but okay, here we are at time 2. I'm gonna ask some of you to do the average rate of change from 1.5 to 2 seconds, and some of you to do 1.75 and 1.9, and then finally at 0.09. I'll ask you to use a calculator so that it's not tedious. And then the other side of the room, I'm gonna ask you guys to pass that at t equals 2.5, 2.25, and I don't know, we'll just say 2.1. Yep.
Would the 1.09 go before the 1.5, or would that be 1.9? Or what?
And then we're not getting along well today. Okay. So the 4 of you, if you guys could use the coordinate, that A, so this is the pattern. So the 4 of you, I want you guys to use 1.5 as T. Ryan and company, you guys are 1.75. The 4 of you, you guys are 1.9. The 4 behind you, you guys are 1.99. Thank you, Samra, for fixing that. E, whole group of you guys are E, okay? You guys are gonna do 2.1. The 3 of you are F, and the 6 of you behind, you guys are G. So you're using the coordinate 2.5. All right? So figure it out, talk to the people next to you what they got. It was a little disappointing, the number of varied answers that we got. Careful with parentheses. You guys get 56. 56 flat. Did you guys get an answer yet? 60? Okay, so average rate of change, that was this thing in blue. And what I asked you guys to calculate was, well, let's make this guy, I can't do f of 2 minus f of 2 over 2 minus 2. Then I'm gonna get 0 divided by 0, that's a problem. I'm not allowed to do that. So I'm gonna push this closer and closer. So this group got 56, and then as we got the time closer, we got 60, and then the time got closer to 2, we got 62.4. Then going on the other side, 2.5. We got 72, that seems an overestimate. And got closer and closer. What is it? Anybody got a guess what the actual instant? Yeah.
64.
64. So this is what a derivative is. If I say 2 plus a smidgen bit of time, I'm not going to give you a specific bit of time, I'm going to just call it h, and subtract the position at 2 over the change in time. And I'm going to make that smidgen smaller and smaller and smaller till it's become 0. F of 2 plus h, all right. That's 2 plus h squared, which is 4 plus 4h plus h squared minus f of 2, oops, I didn't multiply by 16. Try again. So 16 times 4 plus 16 times 4 again. Sorry, I just decided to not erase that last time. 16 times 4 is 64. Those guys cancel out. And I have 64h plus 16h squared divided by h. Nijoni, when I plug 0 in, can I plug it in right now and get a number? No. I get 0 on the top, 0 on the bottom, and 0 divided by 0, I can make it anything I want. Sometimes it's undefined, sometimes it is 0, and sometimes I can make it 1/7. How we're going to get around the problem? I'm going to factor an h out. So before, as I was doing the average between 2 and a smidgen, and then I shrunk that smidgen up. Now I can plug in 0. Now I can say the average from 2 to 2, exactly 2, is going to be, plug in this 0 for that h, that goes away. The instant rate of change is 64 feet per second. Average from 0 to 2 seconds ended up being 32, but instant rate of change is 64. And I did that by doing the average between these two guys, some f of x and some f of x plus a smidgen, and I made that smidgen go to 0. I couldn't plug it in immediately, but eventually it washed away. You guys in AP Physics or Honors Physics or what? AP. Did they teach you all of calculus last week? Mr. Jacobs used to do that. He's now at Blair. But
We started today.
okay, well, Mr. Jacobs would teach one day derivatives, one day integration. Go.
Yeah, that's what we're getting to.
Yeah. You're gonna be miserable till December, but there will be light at the end of the tunnel. Maybe it's not the oncoming train. Anyone else in AP Physics? Yeah. Miserable till we teach you integration. Alright, so we just did a derivative, by the way. This is the limit definition of derivative, and this is what we're basing all of chapter 2 on. And we will do lots more of these tomorrow. And now something completely different, because that's the way the textbook's laid out. I'm sorry, I really ought to change things, but I didn't. So, completely different. If sometimes like, I can't factor this, I can't reduce things. So, I'm just gonna look at a picture. And here's what that graph looks like. Sine of x over x. And I know there's no scale on the y-axis. But as we go to 0, Martha, where does it seem that the y value is going?
Decreasing. Oh, wait.
What's the y value? As x goes to 0,
Oh, it's 1.
it's 1. So, here you go. Can you guys write this down? This is one that we just expect you to know and memorize, and when we get to chapter 8, I will show you analytical way to manage this, but for now, we're just gonna do this. So that's read, the limit as x approaches 0 of sine x over x, it's 1. And as a broken record, I do this every year. I ask students to make images of math concepts. So, for example, this one, it's the word sine x written as a square. So sine x squared plus cosine x squared equals 1. Yeah, cool. Yeah. I lost my favorite one, which was a signature of John Hancock signing the Declaration. So John Hancock in a square, sign, he's a signer. And then all the other co-signers on the Declaration here equals 1 united nation. Har, 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 sine squared. Yeah? Yeah. Just wait till product rule, cocoa beans and corn, you're gonna love it. Okay, that said, this is Maya's. She's working at an NGO in DC, doing lots of good work with South America. Anyway, this is the limit. See, the dude is coming to the edge of the cliff, and the little rocks are falling off, but he didn't fall. So he reaches but doesn't fall. See, he's really close. And okay, here, the x is approaching the 0. The x is getting frisky, like going after the 0. She's getting frisky. Okay, in sign language, x over an actual x equals, we're number 1, yay! See? It will be on the board all year. You can look over there and cheat. I won't hide it. Get it? I don't assign it anymore. Someone gave me inappropriate images of tan lines. I can't unsee those images. I don't assign it anymore. But some of them are classic. All right. And one year I didn't show this thing, and people were like, I don't understand. If I turn it upside down, clearly the graph is going to be different, but at 0, let's look. So we just said sine x divided by x. Uh-oh. Okay. Got to spell it right. So there's sine x over x. Here is x over sine x. At 1, what looks like it's going on? Or sorry, at 0. The limit is still 1. So I can turn it upside down and it's still 1. If you need to write that one down, do so. And the AP, they hate you. They do. They have a thing against children. They will do this. Vastly different question. All I did was change that 0 to an infinity. What does that do? Okay.
It's asking for the end behavior as it approaches.
Okay, what is the end behavior?
I think it's 0. I mean, wait, I remember, yeah, so it's 0.
Is it 0? Does not exist. All right, let's think about it. What's the biggest number that comes out of sine? 1. What's the smallest number that comes out? Negative 1. All right, so I'm feeling like bigger. I'm gonna go with 1. I have one, I don't know, let's pick cookies, and if it's after lunch, we want the dessert. I have one cookie, and I'm obligated to share it with all of you, and then Tyrion tells people down the hall, then they want some cookie, and then they told the rest of Bethesda. Now I gotta share the cookie with the whole world because you opened your big mouth. How much cookie is everybody gonna get? Y'all ain't getting no cookies. You're not getting nothing. It was an idea, between 30 of us, we wouldn't get a lot of cookie, but we would have gotten some. But if I have one cookie to share among the whole world, you get an atom of an aroma of that cookie. At most, like you get nothing. So this one, sin x over x, as we go to infinity, that's gonna go to 0. Let's bring that back up. Oh, cursor. So as we go to infinity, it levels off. What is the other one upside down at infinity? Does not exist? Yep. Big time does not exist. It's super cool. It is so insanely like this is what they're talking about between does not exist and undefined. This is like it's so colored in. You're unimpressed. Look, solid. All right. Since it's here, can functions cross the horizontal asymptote? Okay, one person is saying yes. Okay. Here's a function that clearly the asymptote's at 0. And it crosses the asymptote so many times in the squishy middle. How can that still be an asymptote then? Yeah.
Is the ends of
Okay, the ends, end of time, when x is super duper positive infinity or super duper negative infinity, it does something predictable. Here, it's having its wild, crazy teenage years. Roar. And then, graduates college, gets married, buys a house, gets a dog, and settles off and dies. Cool. Sorry, happy ending? I don't know. Yeah, this thing awesome. Just a warning, most of my examples are kind of dark. My background is computer security, and I did a lot of projects with defense, which involves also offense. All right, don't write this down, just look at it. Pre-calc, limits. You guys, here's the function. Maybe you graphed it and looked at it. Maybe you factored it and plugged into the leftovers. We get 2. This one is the limit as x approaches 1 of this graph still 2. Okay, I heard maybe, no, and yes. Okay, what is a limit? The limit is you are blindfolded and I'm not telling you what direction you're coming from, but you're blindfolded and you're walking along that line. If you were going to guess, Esther, if you had to guess, you're blindfolded, you're coming this way, where's your foot gonna fall if you hit x equals 1? Now, you're cheating, you're peeking. 2. Like, you're blindfolded, where are you gonna go? You're like touching around, you're gonna be like, I'm gonna guess that it's gonna land at 2. We were jerks, we pulled the chair out from under you and we moved it down. But the limit is 2. This one, the limit from the left, the limit from the right, and the function's filled in, there's no problem at all, it's just 2. Great, we're okay with limits? Apologize, this next thing you got some writing to do. First thing is, here's the givens. I'm giving you some letters, it's from alphabet soup. L, M, C, and K are just some real numbers. Alphabet soup. Can you see? Alice? Jacob, sorry. You're giving it, think you got it, good, or are you just waiting?
No, I'm just trying to see what's going on.
Nothing's going on yet, because I haven't told you anything. What's your favorite number?
4.
We'll put them both together, 1 and 0. The limit as x goes to some number, Max, I'm not telling you which one, but as x goes to some number, where's that value going? Yeah. Plug in C for x, and what do we get? There's okay. It's still 10, what this is asking, this is the equation. Y equals 10. All right, here's my equation. Oh, when x is e to the 5th, what's the y value? 10. When x is negative 7.49, and when x is, you don't even care, it's constant, it's always going to be 10. So, here is one rule that you have. The limit as x approaches some value of a number, it is that number. You have no x value to plug in. Okay. Going with the analogy of this being the function, y equals x, then what would the limit as of x be as x approaches c? With what? Okay, let's give it a number. As x approaches 2, what is this value going to be for y equals x? What? 2. Okay, well, because you plug in 2 for the x. Okay, it's not 2 anymore. It's now c. What's it going to be?
C.
Yeah, it's whatever you plugged in. Caden, if it was x squared, what is this going to be?
C squared.
C squared. It's just going to be plugged in the value that I asked about. All right. We had you do limits in pre-cal last year, and you did this fine. We're just generalizing it now. Okay. This one says you can pull it apart. The limit of that guy plus or minus the limit of this guy, well, it's L plus or minus N. That's what it's going to come out to be. freak question? You would never do this because it's irritating. But pre-cal last year, you'd just be like, well, I'm gonna plug in the 3, and that's 3 plus 2, and I'm gonna get 5. But this is saying, you could have said, the limit of this piece that I need to plug something in at, and then add the limit of the constant. That's all. Look. It works with multiply, it works with a constant, and it works with division as long as this is not 0. So these are 3 other rules. And we're going to practice with them in just a minute. Okay, so there's your rules. You good? So trying these. Try the first 2. Compare your answers with the first and next 2.
Okay, that's how I was the second one.
Okay, I'm told, I believe the answer to the first one is 9. There was nothing tricky to it, which is confusing to some of you because you're like, wait, this is calculus, nothing's easy. You're right, the ship has sailed after these 2. The second one, do I need to factor and reduce?
No.
No, I can just plug in, because it's -2, not +2. It was probably supposed to be a +2, but whatever it is, what's written. So I can just plug in. And I get -1? Okay. All right. All well and good. And now the party's over. And these two, can I just plug in?
No.
They both come out to a number though. They both can be reduced. Esther,
Oh,
what,
oh, for the third one, you get 0 and 0.
third one, if I plug in, I get 0 over 0, which sometimes, bummer, it is what it is. But can I do something to get rid of that divide by 0? Nadia, what do you think? For the third one. Factor it? Okay, how does it factor?
X plus 3, X.
So pre-cal, cross them out, and now plugging into the leftovers. Ashley, what do we get? 4. Okay. Sebastian, the last one, number 4. Sebastian?
Okay, yeah, multiply by eight.
Okay. From honors pre-cal, y'all do not like complex fractions, so fractions and fractions, you just hate them. So, if I divide by 2/3, I'm actually multiplying by what?
3/2.
Multiplying by 3/2. So if I'm dividing by x, doesn't that mean multiply by 1 over x? So I'm gonna do that. So y'all do not like fractions and fractions. This at least gets rid of that. But inside the parentheses, I have a problem. I need to smush them together by doing
Finding the common in the denominator.
common denominator. This one is missing a 2, and this one is missing 2 plus x. You can't just multiply the bottom, you gotta multiply the whole thing, because you gotta multiply by 1. Nico, what happens in the numerator?
In the numerator,
Yeah, so what do I get up top when I do that common denominator?
negative 2x plus 2 minus
So 2, and then distributing the negative here. Numerator up top, 2
x
minus 2 minus 2 minus x, not 2x, but 2 and the negative 2 go away. David, does anything reduce? Okay, I'm gonna rewrite it. How does anything reduce? The x's. So, before I cross the x's out, plugging in 0, I get 0 divided by 0. Now reducing them, I have a negative 1 up top. Plug it in the 0 for x in the bottom, I get 2 times 2. Negative 1/4. Yay? Okay, I need to show you the last tricky one. Because this, you might see something like this on the homework, which, oh. How much time do we have left? 5 minutes. You guys try that. And. Fine, we'll give you the textbook.
Oh.
Yeah,
Alright, guys, actually, so I can make sure that it's, can you come back and get one?
Sign over X's.
Oh my god, it's not this slow. No, I don't know.
So sign over X is one.
Guys, did you grab a book from the
Oh,
back?
the limit
of
as,
the
the limit as X is equal to.
Here, okay.
What a bite.
Should I write it on?
Then what'd you get?
Okay. So, that.
Yours is, okay, you're really, I like